Welcome to Brain Vision.
In this question, we have a fish that is attached to a spring, the lower part of the spring, and this is initially they are at equilibrium, that is, the spring is not stretched or compressed, and it's at its natural length. And subsequently, this fish is then released. We want to find what is the speed when it is at a distance of 0.05 meters from the initial position. So after it has moved down by 0.05, now we know that some of this energy, right, which is basically the gravitational potential energy, is converted into kinetic energy and the elastic potential energy of the spring. So we can find the kinetic energy by taking simply the gravitational potential energy minus away the elastic potential energy that is stored in the spring. Now the gravitational potential energy, we just take mg times the distance, the height that it has traveled. Elastic potential energy, half times the spring constant times the distance that the spring is stretched, squared. Solving for this value, right, we substitute all the values in. So mass of our fish is 3 kg, the spring constant is 900 Newton per meter, so we should get 0.345 joules. Equate this to half mv square, so we should be able to get what is our v by dividing the mass of the fish over, which is 3 kg, multiplied by 2 and taking the square root of everything, we should get 0.48 meters per second. Now to find the maximum kinetic energy, this is not as simple, right? We will have to look at the entire expression for the kinetic energy based on our previous explanation, right, which is equals to the gravitational potential energy minus away the elastic potential energy that is being stored. So this mgx minus half kx squared. Now we don't know where x will be. It will give us a maximum kinetic energy. So all we need to do is to differentiate kinetic energy with respect to x, and we equate this to 0 to find where the kinetic energy will be a maximum for the value of x. So differentiating the kinetic energy with x, we get mg minus kx equals to 0. So it is at a point where the force from the spring is equals to the gravitational force, right, or the weight. And so we can solve what is x, taking mg over k. So this is the extension, and at this particular extension we can substitute in to solve for the kinetic energy. Right, the constants are still the same. K is 900, mass is 3 kg. Kinetic energy for this case is 0.4801 joules. And so the velocity, equating this to half mv squared, can solve for velocity v to be 0.566 meters per second.